get started. We have our panelists here today. We're going to be talking about one of the first AFFF cleanouts transitions to fluorine-free foam that occurred using the PerfluorAd technology on a major West Coast airport. We're pretty excited about this project, and we've got some panelists here to discuss. So without further ado, I'd like a quick introduction, and I'm thinking, David, you go first. If you could introduce yourself and then pass it on.
Hello, everyone. I'm David Fleming. I'm a founder of TS Group, and I lead the business development of this part of our business, AFFF Cleanout and treatment of PFAS in water.
Randy, this project kind of starts with you. You want to talk about your role with this project?
Yeah, hi everyone. I'm Randy Krause. I'm the fire chief at Seattle-Tacoma International Airport, Port of Seattle, and been here for 14 and a half years. And the PFAS situation, or resolving, moving from AFFF to a fluorine-free foam, is definitely a high priority for myself and my team. So I'm looking forward to the dialogue and discussion today, and just want to make a note to everybody that it will be interactive and questions are important. So please fill up with a lot of questions. I can speak from my experience and our partnership with TRS. So I'm looking forward to not only learning, but sharing what we've learned.
Yeah. And lastly, Gorm, Mr. Technology.
Okay, Gorm Heron, Chief Technology Officer for TRS Group. I'm involved in thermal remediation and also all the PerfluorAd services, and I'm happy to be here.
So we have some questions that I'd like to ask the panelists today, but I'd encourage all of you listening in to go ahead. At the bottom of your Zoom screen, you are going to see an icon that's labeled Q&A. Open that up, and as we go, please be free to ask whatever question you want. We will try to address as many as we can during today's Bringing the Heat webinar, but we will follow up in writing with each and every one of you and make sure you get a copy of an explanation or an answer to the question asked. So please fire away. So with that, Randy, you know, you're really the first, and as a result, you had to pave the way here. Where is your motivation coming from? How did you know that you needed to address this PFAS residuals problem as your airport, considered your department considered moving away from AFFF and moving on to the new foams? Where did that motivation come from?
It's interesting, Lauren, that you asked that. I actually approached the FAA probably 10 to 15 years ago and said that I believe that AFFF was going to be phased out in my lifetime as a firefighter. I just felt that it wasn't safe. We were starting to hear environmental issues. I want to first say again, we were led to believe that AFFF was safe. And come to find out, it was, a persistent chemical because of the bond, and it's a forever chemical with PFAS, and it's very stubborn and hard to get rid of. And because of that language or dialogue starting to happen, I approached them to look at alternatives that were not foam related. There's things that bond at the molecular level that inert the fuel molecule. So my interest in this started over a decade ago. In just thinking and exploring kind of what would be possible. And then fast forward to 2018, it was more present in the state of Washington, through legislation, which I testified in Olympia at our state capitol in regard to supporting getting rid of AFFF. And so the state of Washington banned AFFF for sale and use in 2018, and that we could only use it for emergency purposes. And at a conference of 300 to 400 participants in 2018, I stood up when the FAA was presenting and said we were going to be the first airport to transition to fluorine-free foam. And I said that I did have everything lined up for October of last year, which would have made us the first. We definitely are the largest airport and the first to transition with a cleaning process to the detail and complexity that we have done. And I'm really happy for that because we did it in the way that I had envisioned it back then, to get the trucks as clean as possible, to make sure that we do our due diligence there. And in the end, very happy with the partnership and the collaboration that we had with TRS, to be successful and actually currently have 5 clean trucks or F3 trucks in my bays and a stockpile of supply to replenish those vehicles if we were in need of using it. So I hope that answers the question.
Yeah. Doing right was the goal kind of all along. So you mentioned, wanting to do something more than just water. Gorm, Mr. Technology, to put you on the spot, why clean AFFF infrastructure? We hear that question all the time. Why do something more than water? Do you care to answer?
Yeah, I would love to, and we have a couple of slides just to show visually. On the in the middle here, you see a foam tank that was cleaned with triple rinse, and that's just clean water run through very, very carefully, many times through, and appears to be pretty clean. Then on the right, what you see is the same tank after we took a pressure washer to it and sprayed the surface in there. And that foam is full of PFAS, and would have eventually bled into the new foam if you had put the F3 foam in there in the stainless steel beautiful tank you thought was clean, and you did, what the FAA once said was best practice. You just did it with water. All that PFAS would petition into the new F3 foam, and you would be thinking you had new fluorine-free foam, but you wouldn't, and the mil spec says 1 microgram per liter or maximum in the new foam, and this would make the new foam concentrate rebound to like thousands of times above that mil spec. So that's the one reason, if you think you have fluorine-free foam and you don't, and you might now spray it and use it, there are 2 things. It may not work as well. There's compatibility issues between the new foams and the old AFFF. It hasn't been cross-checked with all the different combinations that it actually sprays and puts out a fire as it should, because the testing is done with pure foam F3 without these AFFF residues. Another view of the of the PFAS and the crud that can be left inside a fire truck or a fixed system if you just do water rinse is what you see here. What you see is our so-called washing machine, as we call it, or our circulation tank. It creates warm, soapy water, and the soap here is the perfluorad agent. David will talk about more, but it basically makes this hot, soapy water that then is circulated hundreds of times through the vehicle and the pipes and the nozzles and the proportioners and the turrets and all that, hundreds of times at a warm, soapy rinse. So out comes this stuff. This you see in the tank was all left after the water rinse and would have been left in the system if you hadn't done the basically the proper cleaning with the heat and the soap. Just like a dishwasher at home, let's say you forget to put the tablet in and your hot water heater doesn't work, you have a clean water rinse cycle of your dirty dishes. You'll notice they're not clean at all, right? There's all kinds of stuff on them. But with temperature and the surfactant that the soap is and perfluoride also is, you get a deep clean and you get clean dishes at the end. So that's the difference. You don't want to just do it with water if you care about what's left inside the vehicle and whether the new foams will work properly afterwards.
So David, what is this hot soapy detergent that Gorm's talking about? Can you explain a bit more about the detergent that you're using?
Sure. So Gorm referred to the name of it. It's called PerfluorAd. And this is a technology that was invented by a partner of ours in Germany, Martin Cornelissen. We licensed the technology into North America for AFFF Cleanout. And the way this works is the perfluorad is a biodegradable plant-based oleic acid, and it is a positively charged molecule. So when it comes into contact like you'll see here on this little video in the middle, which is a flask of water with PFAS in it. PerfluorAd's added to it. And once that perfluoride contacts the PFAS, the negatively charged PFAS, it forms a weak ionic bond that results in a particle that you see there floating in the water. And once that particle is formed, we can then use sedimentation and filtration to remove it from the water. And one very unique and valued characteristic of this approach is the fact that we're able to clean the PFAS or NAFFF off of the wetted surface, interwetted surface of a tank or a pipe. But we can also use the same process to clean the PFAS out of the rinsate, allowing you to discharge the clean water on site. And that has tremendous value, saves money, liability compared to offsite disposal. At the end of the project, we do have a residue you see there to the far right. Solid waste does require offsite disposal, but a very small amount. And that's another part of this is we're very focused on minimizing the amount of waste that's generated from a project.
Thanks, David. So just to elaborate a bit, because we're starting to see a lot of questions already coming in, and Mr. Weiss, he always has the good questions, right, Rick? Rick has asked, what are you doing with the rinsate? So what you just described is you're actually treating the rinsate on site, and then you have a sediment that needs to be managed essentially at the end.
Mm-hmm.
What about the AFFF? Are you able to use PerfluorAd to treat the AFFF? That's also Rick's question.
Yeah, no, we don't. That AFFF concentrate is first removed from the system, the firefighting system, whether it's a mobile, like a vehicle, truck, trailer, or fixed asset, storage tank, sprinkler system. We're doing both those, and we remove the AFFF concentrate first. We're not treating that; it's too high in PFAS concentrations. That is disposed off-site, along with the first water rinse. So we do a potable water rinse after the concentrate is removed out of the system, and that's also very high in PFAS concentration. So that, along with the concentrate, is disposed off-site.
Yeah. So Randy, you make the decision to use something more than water. You're using PerfluorAd before your foam transition. Can you paint the picture and just provide an overview of some of the steps that your department made to get this project underway? And now that you're on the other side of it, what mattered most during implementation?
I think I feel very fortunate that I had and have to shout out to my executive team here at the airport, because they've been nothing but supportive since that 2018 declaration of wanting to be the first. I've had our government affairs, our executive overseeing the airport, my boss, legal, environmental, risk management have all been very supportive. So that first and foremost has contributed to what I think is our success and being able to leverage this. But we originally had to explore, once we made the decision that we were going to clean the trucks, there wasn't a foam product back then available. There was nothing on the QPL. So we focused on, what cleaning technologies are available. So working with our procurement department, we were able to put out a request for proposal to see what was available. We were interested. I was aware of TRS at the time, but I also didn't know what was available in the market. And I think what I have learned and what will, I think, evolve out of some of the questions I see coming in today is that we're still waiting for answers to information, or many airports are waiting. I'm not, we're done. But many airports are waiting for answers to questions that they still have. And I think it'll lead into some of our dialogue and discussions here. We'll talk about that, because rebounding is a big issue. How clean is clean? All those things. What we did is we wanted to do our due diligence. Our priority was to get the trucks as clean as possible with the least amount of waste. That's how we put out the proposal. Clean as possible with the least amount of waste. And I see a question that's already lined up, and I will go into it more later, not in detail here. But we don't know how clean is clean, and we don't know what rebounding is. But I'm committed to finding the answers, because am I going to treat this new foam different than the old foam? originally, when I started this process, I was absolutely going to not treat this new foam any different. But based on the results and what I'm seeing is I don't have the answer today. I think I'm going to be able to treat this new foam differently than I treated the old foam, because it's going to be, we've cleaned it to a point that I feel very confident, as long as my environmental team is also confident, that we may be able to discharge on occasion in certain areas, to do testing of those trucks and get new information. So I'm pretty optimistic. Our initial data we'll talk about a little bit more, is very, very promising. So priority
Yeah,
was
Randy,
clean.
if I could just ask a
Yeah,
question that came in from the audience.
yeah.
Someone's asking if it's pointless to just put new, F3 in without cleaning it first. I guess they're curious if it needs to be cleaned, or if you could just go straight from AFFF to F3. And if you could just explain, how that was a choice that you made kind of early on, that you needed to do more.
It depends on what your goal is.
Mhm.
I would say my answer to that would be absolutely, for me in my airport, and our philosophy on doing the most right and the best that we can to be advocates and agents of change to make a positive impact on the environment. I would say that you not cleaning the tank, or not taking any approach, draining the tank and putting new foam in, is probably not appropriate, because there's a lot of unanswered questions, and Gorm talked about it. We don't know how that AFFF, if you have a significant residual AFFF in your truck and you put new foam in, the new foam, you're immediately exceeding the new foam requirements of the specification, and you're not compliant, in my opinion. And I'm the least technical here, but I'm very common sense and practical. That just doesn't make sense to me. You would immediately exceed the mil spec requirement for that new foam. So I would say no. And I think if you would ask the FAA, I don't speak for them. I like to pretend that I do, but I don't. But you would be exceeding the mil spec requirement for PFAS allowable in the new product. So that doesn't make sense to me. So that would drive me to say that you should be doing something. What that is, I don't. I believe I've been lucky. I have a great team here, not only with our executive team, but my fire department members. The men and women here have been very supportive, and this has been a significantly important issue to us. So I'm going to reiterate, our goal going in was get them as clean as possible, whatever that means. There is nobody defining how clean is clean. We defined that ourselves. And we wanted to make sure that there was no way that the Department of Ecology and my environmental team, I have to say, stood shoulder to shoulder with me on this. And our goal was, we don't want the Washington State Department of Ecology to come back and say, were there methods of cleaning these trucks available to you at the time that you did something? If we did not,
liability, right?
if we did not, that liability. So if you just drain your truck and put new foam in, there may be a point in your state that they're going to tell you that that wasn't enough. You need to clean your trucks. We don't know that. So those are unanswered questions out there. So I would suggest, don't do what I've done. Do your due diligence, do your research, explore what's available, and make the right decision for your airport. If you're at an airport, specifically with your ARF fleet, because that's what I've experienced. And I wouldn't have gotten away with that here. One of the things, even with us, we haven't gotten rid of our waste. Waste could be a question. So that's like for David, our AFFF, we drained it. So we have totes of AFFF that we're going to have a third party take it off site. And we're even struggling now. We believe we did the most right. We did used you guys as a cleaning technology. We cleaned the trucks. So we think our trucks are safer, way safer than what I had anticipated, because the cleaning was way more comprehensive than I expected. But now we're in a decision of how do we dispose of that waste? And so giving you some parameters of how we think at SeaTac International Airport is, we want to do our due diligence. We don't want to just to get it to any waste provider that is out there that will take care of this waste. We want to make sure that they're taking care of that waste responsibly. So we're not going to, we want to make sure that those forever chemicals are gone forever. not show up somewhere else. So that's our goal.
It's a big ask right now. A lot of folks are already chiming in about connections and how, you dealt with apparatus that did come in contact with the AFFF. Would you mind explaining? I know you have a graphic that you wanted to share with folks just about the process itself. Could you walk the team through?
Yeah, we've kind of covered on it. And I actually I learned something every time I talk to Gorm. That's not so so one of the things, and don't focus on the small print in this graphic. Gorm had talked about that these trucks are cleaned and their circulation process is hundreds of times, and that I forgot about that. So when I've been presenting before, I say that we do 3 or 4 PerfluorAd rinses. Those PerfluorAd rinses, we create flow paths. So we create flow paths. So if you see that circular chart, that one PerfluorAd rinse, we do 3 or 4 of them, is running for an hour to an hour and a half to 2 hours through the system. So it's not just a once run through and done, when you said that hundreds of times, Gorm, it made me think that we are way cleaning these trucks in excess of anything that I had thought or envisioned prior to bringing you guys on site. So once the hoses are connected, I will put a shout out to our mechanics. I believe I have 2 of the best ARF mechanics in the country here at Seattle-Tacoma International Airport. And here's an example. When you're asking about connections and hoses, most of the hoses that you use for your standard connections are absolutely appropriate. So if you have 2.5, you need to put your 2.5 into a 2.5, and they create flow paths. But there may be some manipulation of the trucks because the trucks, when we push a button, I'm a firefighter at heart. When I push a button, water goes out. Water goes out. That's what we do. As a driver of an ARF truck, for those of you in the audience that do that, you flip the switch, water and foam combination go out. That's what it's designed to do. But what we did partnering with TRS's group on the ground is we created flow paths. So they had to manipulate some of the valves to create these flow paths, as Gorm had mentioned. And those flow paths, so for example, a PerfluorAd rinse, first drain the tank, water rinse, then PerfluorAd, actually water in the tank, drive around to slosh to get as much out, drain that. Then we would do a PerfluorAd rinse, and that PerfluorAd rinse would run, and they would agitate and circulate within the tank for an hour and a half each cycle at least. So that's churning and going through what Gorman mentioned, that dishwasher. It's going back through with PerfluorAd and through the filtration and getting rid of as much of that PFAS as possible. So my aha moment already, I've learned I'm done for the day as far as my learning, but Gorm, you said hundreds of times, which is true. I've been short selling that because I've been saying, we do 3 PerfluorAd rinses or 4 PerfluorAd rinses, but those rinses are running through the trucks. If you can go back to the slide and let me talk about, Lauren, the adaptations, my mechanics. We were struggling, and this is kind of our more complicated piece when we talked about modifications. Steve Pistol from TRS on the ground. I got to put a shout out to Steve because he was phenomenal working with him out here. And
hi, Steve.
we had an issue. So this is the Rosenbauer bumper turret, and if you look on the left hand side of the slide, that's your turret intact. Well, if you look on the right, they were struggling. It was July 3rd. Mechanic came to me in the afternoon. They weren't able to get a good seat on that turret with some things that they were trying to do. And he goes, I have an idea. Can I come in on 4th of July? We gave him a different day off. So he traded a day. He came on the holiday and he modified what you see on the right-hand slide as an adapter to tie the threaded hose into. But when we pulled off the turret, as you guys are aware, it's there's dry chem. There's a dry chem orifice where they put a piece of pipe to block the dry chem, or we would have contaminated the powder that was in that system. So they not only did he create this fabricated this little piece to tie the hose in to create the flow path, he created that looks like about a 1-inch pipe piece with an end so that we wouldn't contaminate the dry chem. So working on the ground with TRS's team, for those, note to all of you, if you're looking at using a cleaning technology, no matter which one you choose, you need to have mechanics or somebody that's more intimate with the truck, the flow paths and the valving, because we had to, we flipped breakers, we took from 3% on the foam to 6% so that we could create a more open space. And it just proved very successful. So everywhere that PFAS has been in all 5 of our trucks have been rinsed, as I will repeat, Gorm said, hundreds of times. And we're very confident. I hope that answers or addresses that situation.
Absolutely, and it brings up, another question that's definitely hit the chat a couple of times now. But you talk about, every component being rinsed hundreds of times, and these rinses taking hours. What is the actual downtime associated with each one of these truck cleanings? Could you comment on that, Randy? And
yeah, that's a good. Well, and I'll start. I talked to David. I thought with David in the partnership, knowing that this was kind of the first bigger project in the ARF arena for you guys, and we had never done it, was that I thought, well, let's get this cycle down. If it's 7 days, let's get it down to 3. I realized with our first truck, it's not an important of how fast. For those of you at the smaller airports, you might be asking that question. Because it's an indexing and maintaining index. We were able to, with our 5 trucks, cycle these trucks through and maintain index adequately. But I learned it's not about how fast, it's about getting them clean. That's important because you don't want to redo later. So we focused on getting them clean. We cleaned 5 of our trucks and 5 other trucks, and we'll talk about that more a little bit later. And TRS was on site for 4 months. So average, all things being consistent with not counting weekends, they take weekends off, each truck was 7 to 10 days on average if everything's going right. So that's hopefully that answers that.
Yeah, thank you. And that was the first one. There's definitely been efficiencies that have been gained with additional equipment being constructed and put in place. I know some other airport cleanouts that are underway. We've seen that duration shorten up about half of what you just described. So already progress that's happening. So Gorm, I'd like to turn things back to you. There's been some questions that have been received about the sampling program and the results that were observed at the Seattle airport. Would you mind? I know we've got a slide that shows what happened inside of the trucks, but there's some additional questions I'd like to ask you.
Yeah. So basically, how do we know that it's clean, right? We basically drain the AFFF, and then we do water, send water through everything and in and out of the circulation tank. And we call that the first rinse. This is before any real cleaning, just water circulation. We take a sample of that water, analyze it for PFAS, and that's what you see in the red columns here. Those skyscrapers in the back, that's the before any PerfluorAd rinsing, the PFAS analysis. We've circled PFHXS and PFAS here, showed PFAS down there at 200 and some thousand nanograms per liter. So that just documents that we had high concentrations to begin with. And then we do the PerfluorAd rinses, and as you described, they take typically 3 to 4 days to do 3 to 5 cycles of that. That's the actual cleaning of the vehicle. It takes about 3 days once it's all set up. And then when we're done with that, we run clean cold water through everything again and circulate it, and we sample that water. And the data you see in the light blue, also called final here, it's barely visible, but that's in front of all the skyscrapers. You see, the bars for the final rinsate PFAS concentrations. And for us to be confident that we've done a good job, they should be very, very low, right? They should be, and as you can see here, they're orders of magnitude lower than the starting concentrations.
Yeah, in most cases, non-detect, right?
Yeah,
The empty
and
boxes. Yeah.
and this is just one of the trucks we had. We have the same data for the other ones. Yeah, that's our data. We also have visual data because as I showed in one of the first pictures, if there's still PFAS in there, you'll get some foaming, you'll get some nasty looking water. So we also have a visual indication towards the end of the number of perfluoride rinses. Let's say we do 3 of them and the water is super clear and there's no foam. We may not have to do number 4 and number 5, but if in the 3rd round the water is still picking up stuff and there's still foam and bubbles and things coming out, then we'll for sure do at least 1 more cycle. So we have the visual. Steve Pistol and Greg Knight and others know by now, how to, whether the water is reasonably clean or not. They can basically look at it and tell us. So that determines kind of if we do another couple of cycles and do it.
Just a quick comment about the graph.
Yeah.
Gorm came in. The units on the data here. Can you explain that? Part per trillion, right?
Yeah, the nanograms per liter
Yeah.
that are shown out there. Yeah. So yeah. So if it had been micrograms per liter, it would have been, instead of 1 million there at the top, it would have been 1,000, right? So we're looking at like 800 micrograms per liter for the PFNA, for instance, that's there. So 800 micrograms per liter for just one chemical. The mil spec for the new foam itself is 1. So you have one chemical here that's 800 times what the total can be in the new foam. You got another one, 62FTS, that's 900 times the mil spec max concentration for the sum of everything. So, we're way above mil spec type concentrations when we begin the perfluoride treatment, and then we're down in the same range as the mil spec concentrations afterwards. One thing that we often get asked is basically, this is just water. So you didn't do swipe samples, you didn't do rebound testing. How do we know, like a couple of months later, that your results is still good? And I think Randy would be the best one to answer that because he is.
Randy, what kind of testing are you up to?
So our results our results show equal to or better than what your results show. So we independently tested as well. So we took samples of the first rinse, as Gorm had suggested, and the final rinse. And then everybody's wondering about rebounding. So I tested, because I spoke in Myrtle Beach at the ARF Working Group Annual Conference. I wanted to be able to have rebounding data. So we tested our first truck after 2 months. So the data that Gorm showed there was for first rinse, final rinse. We tested the F3 product that was in the truck, and with a lot of activity. The trucks have been training and driving around and sloshing and doing a bunch of different things. So it wasn't just static. We tested the F3 product, and our F3 product was even better results than what Gorm showed for final rinse, which goes back to the other things. I had thought, and I talked to Steve on site. I said, well, if you have a final water rinse and we're testing that, you're draining that and putting a different product in. It has to be even less again in the F3. So but if there's rebounding, it would be higher. So I would think rebounding, and I don't know, Gorm or David, you may be better able to answer this. I would think that rebounding, if it were to occur, would be in that first 6 to 8 weeks, 2 months. So I have a two-month window that's showing that it's even cleaner. Our F3 product is cleaner than our final rinse non-detect. So which makes me think that I'm going to be able to treat this product differently. And there's a question in the chat asking about discharging and testing for metering, and the FAA requires you to do flow testing or a closed system testing to identify. We have not done that yet because, one, I took a risk because I believe that we're going to be within the parameters. This product, the new products, had to be tested at half strength and double strength. So I know it works at half strength or double strength. So I'm going to fall within that window. One of the departments that did test their trucks here with us without any modifications to their truck got the discharge rate and sampled it, and it was within the parameters that the FAA requires without any modification. So I feel confident, but we have not yet. We will, because I want to see what's on the discharge side, and we'll take a sample of that because we don't know what we're putting into the environment. So our first window of success is that the F3 raw product in the tank is cleaner than the final rinse. So we want to know what we're putting into the environment before we do those testing. And to be honest with you, we're probably going to partner with an environmental team and shoot the foam into their pit. So we have great data at 2 months. I'm committed to the industry because I'm curious. We're going to do it again at 6 months, and we're going to do it again at 1 year so that we understand. And so I am of the belief that the results are going to stay the same.
Yeah. Well, I'm going to put you on the hot seat once again, Randy, and I'm going to go back to one of the very first questions that we received. I mean, we were still giving introductions to the panelists, and Mr. Farmer wrote, "How much does this cost?" So, Randy, do you want to say anything about costs? How many trucks were cleaned? What did your budget look like? What would new trucks have cost your department?
Well,
Please elaborate.
I think so. What did it cost? So I'll answer that question first. We budgeted 300. We have 5 ARF trucks. We budgeted $300,000 to clean the trucks, and I budgeted another $300,000 for foam product. So that's and we've come in under, with cleaning and foam product, we've come in under 500,000. So I have money. I have some. We didn't budget for disposal, but I believe that my 600,000 fully covers cleaning, new product, and disposal. So I think $50,000 to $70,000 per truck is what I would estimate. You guys can. You're the company that does this and works the contract. So I think I'm in that ballpark. But one of the things that people do not consider, I learned this from our friend Gorm, that we chose this particular partnership because we wanted our trucks as clean as possible, which I will tell you in all honesty that those trucks are way cleaner than I ever anticipated. At least our original data, initial data is showing that, with the least amount of waste. I want to reiterate that, with the least amount of waste. My environmental team was able to work with King County and permitting so that we were able to, because you take the PFAS out of rinsate, I would have had 80 to 100,000 gallons of rinsate sitting out in front of my truck bays that I don't have now because I was able to discharge to sanitary sewer. Through our permitting, we were able to, because it was non-detect, discharge to sanitary sewer, saving us at, I don't know, if it's $4 a gallon to dispose of that waste, that in of itself paid for this process. So that's the things that people have to factor in. Cleaning or not cleaning, what are you going to do with the waste? What's your state requiring you to do or not do with that waste? So I feel really fortunate. So for me, it was $600K, and I believe it covered all of our costs.
Can I add to that, Lauren?
There's a question actually about that, David. Yeah. If we're able to treat the rinsate on site and meet discharge criteria. So perhaps you work that into your response.
Yeah. So I wanted to shout out to Randy and his team too for the simple, well, not that simple, but for the straightforward fact that they had, and Randy had the vision for creating a regional center using his firehouse, our equipment, our staff, our resources while we were there at the firehouse at the Seattle Airport to offer a regional center for other local regional airports, smaller airports, so that they too could bring their ARF rigs over to the Seattle firehouse to get those Seattle Airport firehouse to get them cleaned out at the same price point, passing along those economies of scale, because once we move our equipment to one location and then trucks come to us versus moving equipment all over the place, it saves a lot of money. Economies of scale. So the price point per truck we were able to pass that along to these other airports. So King County Airport and Bellingham Airport participated in that. So that was a part of this that I thought was very effective and is being looked at by other airports as well. And it helped get the price down within that range, at the lower end of that range that Randy presented, 50 to 70,000. The higher end of the range is going to be for one-off trucks. If we're just going to a facility and just doing one truck at a time, that's going to be the higher end of the range. But if we can do this regional center, economies of scale, build, a number of trucks together, we can get down to that low range and pass that on to savings on the customers. But on the rinsate treatment side of things, before we did this, and again, I think Seattle and Randy and his team, they were one of the first in the country to work with their local, regulatory authority, in this case, King County Industrial Wastewater, to get the permitting in place to before we actually got to the site, to be able to discharge clean water after we treated it, clean out the vehicle, capture the water, clean the water, and before it's discharged, it's cleaned. So, to non-detect. So, I mean, it's possible to do that. And now we're seeing other states beginning to fall in line with that. California, Indiana, so far have also been able to do the same thing. So, hope that answers the question.
Yeah. Yeah, there's some follow-up questions about the residuals that have come in. Like, what's the volume of those PFAS residuals? What is separated out in the process? Could you comment on that, Randy?
Yeah, so we ended up, so just from my experience with our 5 trucks, we ended up with 7.5 55-gallon drums of waste. That's all we ended up with.
And that
most of that was
sludge and solids and everything.
and your team's PPE.
Yeah, PPE. Mm-hmm.
Yeah, 7.5 55-gallon drums. That's what we ended up with.
Yeah. So, if this is one of the first big ones that have occurred here in North America, so we have to all take a step back. And I think appreciate the fact that we've learned some lessons along the way, lessons that we hope others, don't have to repeat or learn for themselves. You've got an audience here that I'm sure is eager to hear about those. What are some of the key, takeaways that you want this audience that's doing their own considerations on what to do next with their foam transitions? What would you leave them with? Randy, do you want to go first? I might put all of you on the spot with that one.
Yeah. Well, I think for me, if I were to, don't be afraid to engage and start the process. I think a lot of people may be waiting for FAA reauthorization or whatever they may be waiting for. I have been really surprised that we didn't have a rush to market. And I think there's been some indicators within the market that have kind of put people in a position to wait, because there are a lot of unanswered questions, even like within the chat. Does everything have to be dry before you put the foam in? How do you do this to make sure you're doing your due diligence not to damage equipment or other things? So what I would like, do your research, or reach out to those that have already done research. I'm definitely make myself available and my mechanics available for anybody that has any questions or comments. I've experienced this process and am willing to share, because I think learning from others is very important, so that we can help minimize mistakes. I feel really fortunate, Lauren, and lucky. I think I got lucky. I got partnered up with great executive support, an environmental senior manager that is just a rock star with Megan King. And I had good advice, and we were able to line things up. So I don't know if I would do anything different. I just don't know.
Well, that investment, right, in the stakeholders and the partnership, making sure, everyone is aligned, that took time, I'm sure, to establish.
Yeah. And I've learned a long time ago, I've been doing this for many, many years, that your stakeholders and those that are affected by this at your airport, if I miss one of them in that communication, this could be put on hold because they have questions or I didn't answer at a level that they were comfortable with, and they would tell me to wait. And I've been fortunate that we weren't able to do that. But I'm also not naive enough. We're still learning. So I don't want to say that we have this all nailed. I'm pretty optimistic about what I see for our future with the new product. And I wouldn't be afraid to start the process. If you're waiting for money, that's one thing. If your state allows you to wait, that's another. I will caveat this with, I thought we would be doing this in October. That would have
Yeah.
truly made us, I was ready to do this in October, but we had to wait for
Last
another,
year, not this year.
last year. We were
Yeah.
waiting for another foam product to get on the QPL so we could compete it. We weren't comfortable with just one on the list, so we waited till another one was on the list so we could compete it. Outside of that, I think everything's lined up really, really well. So I would tell those in the audience to, if you're waiting, make sure you reach out to your stakeholders and have those dialogue, and that you're ready to do it. And then partner with environmental. How are you going to do it? What foam product are you going to buy? Are you going to clean or not clean, or rinse and not rinse? And that's something, what's the data? Everybody's wondering, is a water rinse, good enough? And Gorm gave this dishwasher example. I don't know what that means. I think if you do a water rinse, I'm not going to say, I can't say anything bad about it. At least you did something and you've started a process. But I think you're going to have to handle that product different through engineering controls to minimize exposures that I am hoping that I'm not going to have to worry about in the same way in the future once we get our data all lined up and out there. And we'll be sharing all of that. There's nothing that we're going to keep to ourselves. We have no problem sharing, because we want to make sure that the industry is informed and learns from what we have done.
Yeah, absolutely. Gorm, you're muted. It looks like you're trying to talk.
Yeah, if I could add to that,
Yeah.
difference between the closed PerfluorAd rinsing system that we have and a water rinse and cleanout is that we have a closed system where you don't get exposed to the liquids and the PFAS in the water, right? If you're trying to do it in a simple way and you're using water and rinsing a system, you could have foam coming out of your vehicle for days, and when you see people doing that, they typically are in these hazmat suits and potentially exposed if they weren't, right? So that's just another thing, health and safety wise. A closed system where the PerfluorAd constantly bonds to the PFAS and makes sure that it doesn't foam up and spread everywhere is also much safer. We can wear lower levels of PPE and not get exposed to the PFAS in the rinsing process.
Yeah. Gorm, would you mind? There's a lot of questions coming in about the rinsate and the volume of waste that was generated on this project and how the rinsate waste was handled. Would you mind explaining how rinsate was ultimately processed at the site from a waste point of view? Where did it go? And then taking a step back and explain, how we could do it at other sites. And David, feel free to chime in. I know you deal with this all the time as well.
Yeah, if you don't mind, bring out Randy's diagram. Sure. It's a little easier to talk to. So basically, we talked about running this hot fluid through the vehicles hundreds of times, right? The diagram, when it comes up, will show you then that, as you see there at the nose of the truck, it goes down into a sedimentation tank. So that's the first, once we've circulated it through hundreds of times, we then go to that sedimentation tank and we do flocculation, as we call it. So we do what David showed in one of the first slides, the swirling and all that, and PerfluorAd binds with most of the PFAS. It drops to the bottom. You see that orange sludgy stuff at the bottom of the cone bottom tank. So there we've got sludge. We actually drop some of that straight into a drum as a liquid sludge waste. Then the water that's now much clearer and lower in PFAS goes down to the filters. You see there, micrometer, it says. It gets filtered through little particles and flock gets taken out, and then through carbon filtration to where once it goes into that Baker tank, it is low enough in concentration that we believe it can be discharged directly. We do sample it before we do that, and if it's not, we run it back through the carbon system again, right? So, like Randy said, for his trucks, he would have had about 80,000 gallons of waste. Most of that would have been that water in the Baker tank to dispose of. But because we're treating it to discharge concentrations, we don't have that liquid waste. We just have the spent carbon, the filter bags, and then the sludge that comes out of the flocculation tank.
If I could add, and what Randy said earlier too, that was a really good description, Lauren. What Randy mentioned earlier, I want to emphasize that just by being able to treat this rinsate to the levels low enough to discharge it on site, that basically paid for the project when you would have compared having to dispose of all that water off site. It was paid for the project. And that's similar to our other projects. It's a similar equation. Treating that rinsate on site to levels low enough that everyone's agreed to, sample, analysis, prove it before discharge, pays for the project.
Yeah. And by the way, Anita, your one question, the temperature is answered here. 110 Fahrenheit approximately is the temperature of the fluoride solution.
Awesome. So David, what is next for AFFF cleanouts? What are you setting up for here as the market progresses? Could you explain a bit about what you're working on? I'll stop sharing.
So we have been focused on primarily getting larger airports like the Seattle Airport and LAX and Denver and others on board to get their rigs cleaned out and transitioned to the new foams. So that's been a big thrust of what we've done in the last year. But what we're seeing now too is for some of these airports are working with the municipal fire departments within their regions to develop a central regional cleanout center for these other fire departments. And so that's happening. And we're also seeing more activity on the fixed system side of the equation where large chemical companies, for example, or others too, who want to clean out their fixed building fire sprinkler systems or storage facilities, tanks and piping and stuff like that, to clean those out to prepare for demolishing a facility, for example, or to transition to a fluorine-free type product or to water. We're doing one right now north of Seattle. In fact, the equipment from the Seattle Airport mobilized earlier this week up to this facility, which is an aerospace fuel research center with laboratories that are transitioning from AFFF to water only in their fixed systems. So we're helping them clean out their systems. So we're kind of seeing a similar trajectory to what we have seen in Germany, what our partner in Germany has experienced, Martin Cornelius and his company, which is transitioning over the last few years from mobile assets, cleaning out the mobile assets, to a lot of firefighting trucks, RF trucks, municipal trucks, to these fixed systems. And we're seeing a similar thing here, but we're a few years behind them.
Wouldn't it be nice to set up at an airport to clean out vehicles and also do some of the fixed systems all at the same time, right?
Hangars, storage systems, other
stuff.
Sure.
That market is
starting. Can I touch
yeah.
on that? Because we had talked earlier that so one of the things for the audience, for those of you that are at airports, Lauren just touched on a really key thing. I had originally thought once I got TRS on site, we'd be able to clean our hangars and our fuel farm, and I would have them here for a year. But because of those agreements and contracts with properties, it's not as easy as one might think. So things to consider at your airport. I originally thought that would be a slam dunk. However, I transitioned to a regional concept, and we had a workshop about 2 years prior to you guys coming in and us being able to do this. And we realized economies of scale and asking for partnerships. So I didn't answer this when you asked the previous question, Lauren, but if I were to have a recommendation for the airports out there, or my airport brothers and sisters out there on this call, is that if you're a larger airport and are thinking about going this way, don't do it alone. Invite the smaller airports within your region or your state. I wish I would have reached out to every airport in the state of Washington so that they could have benefited from this. We were ready to be able to set up and participate that, and they could have lowboyed their trucks here to do that. We were fortunate that we were able to partner with King County Airport, Bellingham Airport. So we cleaned a total, just kind of issuing, being mindful of some of the questions in the chat. We cleaned a total of 10 trucks, 5 Rs, 3 King County, 2 Bellingham, and TRS was on site for 4 months. And that was problem solving. You know, we were the first large process with multiple derivatives of trucks, Oshkosh and Rosenbauer. So that addresses that question. And we believe there's a question also in there about FAA funding through the FAA Reauthorization Act. They haven't defined those elements. I believe that all of our costs we're saving, you know, all the receipts for the cleaning, the foam, and disposal. That we believe that all those costs will be covered once they define what the criteria is. So we're pretty optimistic about that.
Yeah, that's a good point. So we're very quickly approaching the top of the hour, and we've only answered about half of the questions that have come in from the audience. So we so appreciate that level of engagement. Again, our promise to you is that we will follow up in writing. We will type up answers to all of your questions. We consider them all to be very important, but we've run out of time to get to all of them. So I would like to close things out for us, but before everyone departs, you know, Randy, Gorm, David, anything lastly that you'd like to leave with this audience as they face their own cleanouts? Any resources you'd like to share?
I will start with saying that my team, myself and my mechanics and anybody on my team are available if you want to reach out. We've shared our documents for our bid documents so that people can see how those are constructed. And I want to end with my why, which I didn't get to really touch on. We've had 2 firefighters that have passed away of pancreatic cancer. It's really important to me that I do the best and do my due diligence to protect my team, because all of us as fire chiefs out there in the industry, #1 priority is firefighter safety. So that was a significantly unfortunate. We lost 2 great men way too early in their lives. And that just resonates with both me and my team. So that's kind of what drove our purpose of cleaning these as clean as we can so that my future firefighters are safe. And not that this was the direct cause of those cancers being achieved, but they couldn't rule it out that it wasn't. So that's just one factor. I've made my truck safer for my team. So if nothing else resonates with the audience, for those of you that are in a role at your airport, I believe it's your responsibility to do your due diligence, whatever that is for you, to get those trucks as clean as possible.
Yeah. All right. Any final thoughts, Gorm, David?
Yeah, I have one. Yeah, if there's someone out there in a small airport thinking you missed the first train here because, you know, we treated 10 vehicles in Seattle and now we're moving on. We're in Denver right now. We're at LAX right now. Don't worry. It's like we feel like we're musicians and we're giving concerts, and we will go on tour again. So there'll be other times where we probably will be set up in your area, and so it's not a once. There's more chance to get vehicles cleaned, and most importantly, like Randy said, I think is get them cleaned the right way, so you don't transition and have bad foam or toxic foam still, and you stop exposing the environment and your firefighters to the PFAS in the old foams.
Yeah.
And if I could, one parting thought too, I just would like to say to Randy and his team, and just thank you for the partnership. Thank you for everything you've done to help lead this effort, your vision, your commitment, working as hard as you do. Just wanted to thank you and Port of Seattle for trusting us and working with us to accomplish this project, which has had great benefits for all, and we're just really thankful for it.
Absolutely. What a great way to end things, David. All right. Take care, everyone. Thanks for being here. And thank you to our panelists.